Okay, now we're going to cover the material that is in section 2.1 in this video. And again, we're continuing to study functions, but in this section, there's some vocabulary that you will need to be familiar with. So, once again, this document can be found by clicking on Course Content in Blackboard. And under Course Content, of course, you find MyLabs Plus, and you find a schedule of the due dates. And then I'm going to have class notes, which are these documents that you're seeing now. And then we'll have videos. So, if you would like to have a copy of this, you could print it. If you just want to look at it and read it, go to class notes under course content. Okay, so what we're talking about today is where a function increases, decreases, or stays constant. And then, of course, functions have relative maximums and relative minimums. And then there's a special kind of function we're going to discuss, which is a piecewise function. But once again, the reading of this vocabulary is up to you if you need to do it. I'm just going to begin here with example 1, and this is exactly what you'll see in MyLabs Plus when you click on section 2.1. There's a graph. And it's going to ask, where is the function increasing, where is the function constant, and where is the function decreasing? Now these words are self-explanatory, but what you have to remember is you need to look at the graph from the left to the right. You cannot just jump in there and start looking at it from any direction. And you absolutely cannot look at it from right to left. You must start over here, and you've got to say what's happening right now to this graph. If you start at the left, it is decreasing. And then when you get to this point, it starts to remain constant. And then when you get here, it will start to increase. So, try to describe that using interval notation. It's decreasing. Well, they're asking increasing first. I'm sorry. They're asking for where's it increasing. So it increases from, put your finger on that dot and go up to the x value. You always use your x values. And one more thing I can always tell you is you always use parentheses. Never, ever, 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 ever use a bracket when you're talking about increasing and decreasing and constant. Okay, so here's where it started to increase. So you go up to the x-axis, that's a positive 2. And it continues to increase all the way to infinity. So that is choice D. Where is it constant? It started being constant here at negative 2, and it quit being constant at positive 2. Again, you're always using parentheses. So these brackets they're throwing in here is just to confuse you. You want to find the negative 2 to 2 in parentheses, and that is choice B. And then where is it decreasing? From negative infinity. Now see, that looks like it's going up. So a lot of kids get confused there, students. But what you got to remember is you're looking at the x-axis. You're going to negative infinity. That's where it's decreasing to negative 2. With parentheses, that's choice D. Okay, so that's number 1. Now you notice they didn't ask anything about a relative maximum or a relative minimum. That's now coming in number 2. It says identify any relative maxima or minima and the intervals on which the function is decreasing and increasing. You can see the graph there, hopefully. Excuse me. The relative maximum is the highest point. Don't say infinity because that's not what we're looking at. Relative maximum is always going to be the highest black point. It's got to be, by black I mean it's got to be an actual point. So your relative maximum is that point right there. Now, this is confusing. People will say, well, what do I put in this blank and what do I put in that one? Just read the question. They want the x value here, so that means they want the y value in the first blank. So the relative maximum is -1 at -2. Because if you can see that, coordinate right there, it's -2, -1. The relative minimum is this one. Because see, that's the lowest point that's not infinities. So it'll be -33 at x equals 6. So on which interval is it increasing? Start at your left. Sure enough, it's increasing right there. Then it's decreasing, but then it's increasing again over here. So you're going to have two intervals of increasing from -infinity up to -2. See, I'm just looking from the left, -infinity up to -2, and then from that 6 to infinity. -infinity to -2, and 2, oh wait, that's not it. From -infinity to -2, and then 6 to infinity. That is choice B. Sorry, I could not for some reason focus on that small print. But from -infinity to -2, it's increasing. From 6 to infinity, it's increasing. That's choice B. Where is it decreasing? Right in that space right there, from -2 to +6. Choice C. And then this last one, and then we're going to switch over to something else. The relative maximum. Does this function have a relative maximum or minimum? Well, since that's the highest point and the graph is turned down, it's called a relative maximum. Where is that? Now this time they want the x first. At x equal -2.5. I'm just reading off of the graph. I hope my eyesight is good. That's -2.5. And it has a value of 1.25. When is it increasing? If you start from the left, you're increasing till you get to that relative maximum, and then you start to decrease. So it'll be -infinity to -2.5, answer D, and then from -2.5 to infinity, answer C. That's where it's decreasing. Now, the only other thing in this section is piecewise functions. And I have just a few examples of this. Piecewise function is exactly what it sounds like. It's a function made up of pieces. This number 4 is a g of x function made up of x plus 5 and 6 minus x. But here's the most important part. The x plus 5 is 4 x's less than or equal to 3. You'll see that on the handout if you print these out or just take a look at them under class notes. This piece is for x's greater than 3. So if you understand the way this is written, these should be quite easy. For any x that is less than or equal to 3, use this piece. Use this problem. For x is greater than 3, use this piece or problem. So they're asking you, What's g of negative 9? Well, negative 9, remember, these are the x's that's always found in these parentheses, and they're asking you to find the y's. So negative 9 is definitely less than 3, so use that piece. Negative 9 plus 5. That's negative 4. 3, that would fall under this equal to 3 description right there, so you'll put it in the same piece. 3 plus 5 equals 8. And then g of 6, 6 is greater than 3, so you use this piece. 6 minus 6, which is 0. All you have to do for problems 4 and 5 is find the correct piece, put the x in that piece to find y. So taking a look at number 5, we have x plus 7 for the x is less than 4, and 6 minus x for the x is greater than 4. So where are we going to put 4? I'll explain that in just a minute. Look at the first question. G of 0. Is 0 less than 4 or greater than 4? That's what you have to ask yourself. Is 0 less than 4 or greater than 4? Well, obviously it's less than 4, so you use the first piece. X plus 7, put the 0 in for x, and you will get 7. Now, they're asking us about that 4. Where are you going to put 4? This piece is for less than 4, this piece is for greater than 4, so you're just going to say it's undefined. There's no place to put it. I'm not sure if MyLabs Plus will let you use that symbol, but if it does, use that symbol. And then g of 5. 5 is obviously greater than 4, so you use that second piece, 6 minus 5, and you'll get 1. You're using the second piece because the 5 is greater than 4. Now, I have to do one more problem for you, and then that will end this video. I need to do number 6. Because now they're asking you to graph this piecewise function. But thank goodness, you don't have to graph, you just have to pick choice A, B, C, or D. Which one is the correct graph? Now this is exactly what you guys have got to do if you want to make this easy on yourself. Yeah, f of x is equal to 1/6 of an x for the x's that are less than 0, but it's x minus 3 squared for the x's greater than or equal to 3. All right. Now you understand when you're graphing, it's nice to set up a table. Well, I think you need to set up 2 tables. You need to set up a table for the first piece. I'll use a different color here, 1/6 x. And then you need to have a table for the second piece, which is x minus 3 quantity squared. Okay. What do you put in these tables? Well, even though it says less than 0, start with 0, and then pick one number less than 0 that'll come out nice when you insert it. I'm going to use -6. You'll see in a minute why. What's 1/6 times x? In this case, it's 0. 1/6 times 0, 0. What's 1/6 times the -6 that I chose? You choose these, but you always use the first number that they've set up. Use 0, and then pick this one. 1/6 times -6 is -1. Now, here's the important part. Since this said x had to be less than 0, this point 0, 0 is going to be an open dot on the graph. But since it said it could be less than 0, the -6, -1 will be a black dot, or closed dot is the proper terminology. So I advise, since this is multiple choice, just go ahead and look and see if you can find the right graph just based on these 2 points. Where is 0, 0 open? Well, in point A, 0, 0 is not even there. It's not even a dot. So that one's out. In point B, or graph choice B, 0, 0 is on there, but it's black. That one's wrong. Here's a possibility. There's 0, 0 open, but then so it is in here. It's also open here, 0, 0. See that? So both of these are possibilities. Let's look at -6, -1. Now you have to be careful in MyLabs Plus. They've marked these off. These blocks represent 2 because that goes all the way to -10 and that goes to +10. So each block is counting 2, 4, 6, 8, 10. So to find -6, you'll go 2, 4, -6. Sure enough, there's -1. I'm going to go with choice C. Because if you look over here and you go to 2, 4, there's -6, -1. There should be a dot here. Where's the graph? Well, it's way over there. So that one's wrong. Process of elimination. So I didn't even need this one. No, do not need the second table because I figured it out. Just using 2 points that I chose from their mandate. They said go x less than 0. Now, because I know just from teaching all these years that is a little bit confusing, I'm going to do the one last example. And it's another 1/6 x for x is less than 0. 1/6 x for x is less than 0. And x plus 4 for x is greater than or equal to 0. And I've got to choose the correct graph. All right, right now I think I need 2 tables. Last time I didn't need 2. This one's going to start with 0. I'm going to use -6 again because it's really the same problem, less than 0, and it's got a 1/6. This one I'm going to use 0 because that's the indication here. And it says go greater than, so I'll just use, I don't know, 4. It does, just choose something bigger than 0. All right. When I put 0 into this, let me label them. This one's for the 1/6 x. This one's for the x plus 4 piece. Okay, so when you put 0 into 1/6 x, you get 0. When you put -6 in there and multiply it, you get -1. This one's open dot, but this one gets to be a closed dot. Over here, when you put in 0, you're going to add 4 to it, but that gets to be a black dot. How do I know? Because it's got an equal to bar right there. Greater than 0, I chose 4. 4 plus 4 is 8, and that one's going to be a black dot. So you guys just look on these graphs for 0, 0 being an open dot. There it is in that one. It's black in that one, so I'm going to mark that one out. It's open there. See, I'm just looking at 0, 0 right now. This is the only one I'm looking at. Could be that one, it could be that one. Okay, now let's look at this dot. Again, we're counting by 2s because of the way they've set this up. We got to go to -6, 2, 4, 6, and it says -1. There's no dot on -1. -6, -1, that was out. 2, 4, 6, negative. That one's out. Well, we've already ruled that one out. 2, 4, 6, negative. Uh-oh, that's a good one. There it is. -6, -1. -6. Oh, that's close, but I'm thinking that's 2. Yep, that one's out. So choice C. So now we have finished section 2.1. Any questions, of course, always email me.